So welcome back to East Academia. So my name is Brian, and today we are going to talk about continuity. So continuity, this happens when, it happens when the left hand side limit is equals to the right hand side limit, all right? So in essence, what I can write, the condition for continuity, I can write that a limit as x approaches a in the positive direction of f of x is equal to the limit as x approaches a in the other direction, the negative direction, of course, of f of x. So this is the continuity requirement, all right? And all this, whether you're approaching it in the left side or the right side, all these are going to give you the same value, which is the unique limit, okay, which is going to be the same as f of a. Right. So this is the condition for continuity. So we see from this question here, we see that a continuous function, all right, must realize two conditions, which is the left hand limit must be equal to the right hand limit, all right, that is condition 1. And condition 2, these are equal in the value, they are equal to the value of the function. So these limits, okay, so these limits, so LHL is equals to RHL is equals to FA, so they are equal to the value of the function, all right? So that one is the condition for continuity. So you can get a question that is telling you to determine whether a certain function a certain limit is continuous or not, all right, at a certain point. So I'm going to provide an example here. So this example is telling you, determine whether the following function is continuous at, determine whether f of x is equals to x squared is continuous at -2, all right? So the point, or at x is equals to -2, all right? So this one, of course, you are going to evaluate, in fact, not even -2. I can put an absolute value here. Is continuous at 2, all right? So the thing is, you are going to test. First, you're going to say, you're going to have limit as x approaches -2, okay? Let's start with the, okay, let's begin with the formula. LHL is equals to RHL is equals to FA, isn't it? So LHL, this is going to be limit as x approaches -2 in the negative direction, of course, of this one, x squared. Okay, this one is going to give us what? -2 squared is going to give us 4. Then limit as x approaches +2, x squared, isn't it? Is still going to give us 4. And then f of a, of course, is 2 squared, which is equals to 4. So then you will say, given that, so given that LHL is equals to RHL is equals to FA, isn't it? So you can say 4 is equals to 4, which of course doesn't make sense, but that is what it means to prove continuity. Thus, x squared is continuous at 2. So something of that kind, yeah? So that's how we test continuity. And I'm going to give us an example for testing continuity. All right, so let me say that now we can have an example of a question on continuity. So I'll just bring in this one here. And we will try to solve this question for continuity and for the purposes of us understanding how to go about this. So the question says, find a value b such that f of t is continuous for all t, all right? find a value b such that f of t is continuous for all t. And we are given that f of t is bt if t is less or equal to 3, and it has a value of 5 if t is greater than 3. So in essence, when you draw a number line, something like that, all right, and you have 0 here, 1, 2, 3, 4, 5, okay, minus 1, minus 2, that way. And the point of concern now here is what? Is 3, isn't it? So this point here is the point of concern. So anything that goes this side is going to be our left hand side limit, and any point that goes this side is going to be our right hand limit. All right, and unfortunately this equation has different values when going this side, and a different value when it assumes a different value when going this other side. All right, described by these equations. We still don't know, but we want to evaluate and to find a value b such that f of t is continuous for all values of t. All right, so okay, for someone like me, I can easily think of replacing just 3, but okay, let me not take the shortcut. Let us work it out. All right, let us just work it out. So for a function to be continuous, in this case, all right, we want to see that the right hand limit is equals to the left hand side limit, isn't it? Yeah. So in this case, then that means we should, if we take the limit as t approaches 3, bt ought to be equal to limit as t approaches 3. Okay, notice one thing I'll write here. Okay, this one is less or equal to, isn't it? So it is the left hand side limit, yeah? It is the one going this side, yeah? So I will put a dash. I'm not going to put it before 3 because I'll put it above here to indicate that this is a direction, like it's going in this negative x direction, all right? Yeah, that's why I'm going to put it here. And then for this one, I'll put a 3, but I will put a positive sign here to indicate that it's going in the positive x direction. All right, so I hope I've just cleared that confusion, and that is how to go. And we have 5 here, all right? These ones have to be equal, all right? These ones have to be equal. But when you look, limit as 3 approaches to this positive, if it's a 5, this one is a constant value. So of course the value here will just be 5 because it's approaching a constant value. All right. So then in this case, you are going to have 3b, isn't it? So when you evaluate this limit here, you are going to have 3b. So you are going to have 3b is equals to 5. So what is the value of b? b is 5 over 3. All right, b is 5 over 3. So if you put 5 over 3, you're going to have 5. And in essence, this one is going to be something of this kind. The value of t is going to be 5. So it's a continuous function if this one is 5, somewhere like that. But that is how you solve this first part. So you can pause and try to solve this second part before I solve it, before you solve it together. So 2 minutes for you to solve this one, and then let us just read the question first. Suppose that f of x is equals to a plus x if x is less than 2, and it is 1 plus x squared if x is greater or equal to 2. Yeah. Find the value of a such that f of x is continuous at the point x is equals to 2. All right. So in essence, this one just solve it the same way. All right. So where you have x, you put 2. All right. Where there is x, just put 2. So you're going to have a plus 2 is equals to 1 plus 2 squared, which is equals to 5. So a plus 2 is equals to 5. A is equals to 5 minus 2, which is equal to 3. You can go the long way, you can go this shortcut method that I've used, but of course when you're solving for your exam work, be sure to go this direction. So the answer here is 3, and the answer above here is 5/3. So if you got those answers, then you're good. So that is the questions that we had for continuity of a function and how to prove that a function is continuous. So that is it. Thank you. So in the next video, we are going to talk about techniques of evaluating limits.